Greetings, students. Professor Benavides here. Let's talk about conditionals. Specifically, we're going to be talking about Chapter 5, if statements. And I'm going to cut this chapter into 3 parts. The first part will be about conditionals. Second part will be about the if structure. And the last part, we'll talk about using ifs with lists. And we'll also talk about styling. But let me just give you a top-level view of this chapter and introduction. How are conditions and if statements used in programming? So programming often involves examining a set of conditions and deciding which action to take based on those conditions. Python's if statement allows you to examine the current state of a program and respond appropriately to that state. So what will you learn in this chapter? In this chapter, you will learn how to write conditional tests, which allow you to check any condition of interest. You'll learn to write simple if statements, and you'll learn how to create more complex series of if statements to identify when the exact condition you want or conditions you want are apparent. You'll then apply this concept to lists, so you'll be able to write a for loop that handles most items in a list one way, but handles certain items with specific values in a different way. So we'll start off with a simple example, and then we'll branch off from there. But let's take a little detour. I want to go ahead and bring to your attention the cheat sheet that the author has. They're pretty good. I've mentioned them before. So here's the cheat sheet. Again, he mixes too many topics of this. I wish they would only be, he's talking about if statements and the while loop. But this is a great way of, I like to use this before I start the chapter and after I finish the chapter to make sure I get everything in. Now this chapter on conditionals, he does a lot of work at the terminal prompt, okay, or the terminal window. These quick terminal statements that are used here are a very fast way of learning the language. I'll show you how to do that in just a while here, but I wanted to alert you how to the fact that he ends up doing in this chapter a lot of code to the terminal window and just a few programs inside a file. Okay, so in fact, I'm going to go ahead and just demonstrate a few of these to you real fast. What I'm going to do is I'm going to go ahead and use idle and compare idle and compare that with the terminal window or the command prompt. So IDLE, and you know that idle comes with Python when you install it. Now, when you open it up, it does open up to what's referred to as the shell, but you can configure it. Typically, I do 3 things to my idle. I go into options, configure, and I usually change my font size because I need to have a bigger size font. I also like to go ahead and change a few other things. Instead of opening up to the shell, you may want to open it up in the editor. That way you can create a file right away, right? So that's usually a very good thing. And then highlighting from here, you can choose colors, which usually if I do this, I end up making it look really ugly. What I'll usually do is just come over here. Instead of classic, you may want to change it to like dark. That gives you a different view. But I'm going to keep it on classic because that looks better on when I'm making a video. I'm not going to make any changes. The only change I've made is the font style. Okay, so I wanted to just show you how you can go ahead and use this as a simulation of the command prompt. Let me go ahead and open up the command prompt so you can make a comparison of that CMD. And I've already got this configured too as well. But to get to the Python interpreter, you type in Python, right? And from here, you can do some simple things like, let's go ahead and set car to BMW. And then I'm going to go ahead and test to see That's the test for equality. And he returns true. Let's go ahead and do that same thing over here inside of idle. So some people like this because they don't have to go to the command prompt. I don't have a problem with it. I just want to show you that idle is capable of doing this. So it does the same thing. Now, why would I want to use the command prompt over this, even though many people like this better? The up and down arrow keys don't work real good inside of the idle shell. Like if I press the up arrow key here, it just moves me up. But over here in the command interpreter, the Python interpreter, if I use the up arrow key, see how I can circulate through or down arrow key, I can circulate through my various commands. That makes it easy for me to, let's say I typed in something wrong, it's a really long statement, I can go and just press the up arrow key and edit it and fix it. I haven't figured out, maybe you can do that in idle, I just haven't figured out how to do that in idle yet. So that's why, one of the reasons why I prefer using the command prompt rather than idle, you know, on here. So let's continue on here. Let's go ahead and set car to Audi. And these are examples right off of that cheat sheet. I'm stealing them right off the cheat sheet. So the cheat sheets are a way to get to the ideas without having to do a lot of reading. If you're an experienced programmer, you could probably, if you've done C++ or Java before, you could just go to the cheat sheet and in a short period of time, know everything you need to know without having to read the chapters. Okay? So what I'm doing here is I'm assigning Audi to car. And then I'm going to go ahead and see if car is equal to BMW. It's not, but. So it returns false. So here we're seeing a situation where the condition is evaluated and the test for equality in Python is two equal signs together. So if the test is either, the test for equality is going to go ahead and result in either true or false. Now I can also use some of the string methods that we've used before. So for example, if I set car to capitalized Audi, and then I go ahead and say car.lower, typing in the dark, right? Wish I had a backlit keyboard. I had one, but the keys started malfunctioning. They don't last forever. They are expensive. All right, so in this particular case, I'm setting car to Audi. That's an assignment statement. So Audi is, car is set to Audi, and then car.lower converts that to all lowercase and compares it to Audi. So what do you think we're going to go ahead and get? We're going to get true because, but does it you know, change anything really? And no, not really. You know. Because if you print out car, right? Oops, got a look at that. That's good. That was a name error. In other words, CASR. It doesn't know what that is. So if I type in car, it gives me Audi. That's what I wanted to do. This is learning. It's great to do a little mistakes because there you see we have a name error exception because it does not. It says that CASR is not defined, whereas car is. So what I wanted to show you was that even though we had a true statement that car.lower is equal to Audi, lowercase, it did not change the string, right? Because strings are immutable, right? What happened here was that car.lower returned a temporary state and compared it to the lowercase Audi. So then when I typed out car, it showed Audi with a capital letter. Okay. We can also test for non-equality. So we can, let's say toppings. Toppings get mushrooms. You like mushrooms on your pizza? So I set. So now I'm going to go ahead and say the test for non-equality is the exclamation point equal sign. And I love anchovies. I know a lot of people don't, but I do. So, yeah, is this going to work? Yes. So true, right? Because toppings, you know, it does not have anchovies in it. But what if I would have misspelled that? Let's say I think I already did that demo to you, but if I would have misspelled it, then let's say, for example, topping. Let's say I would have been topping not equal to. And I probably should have used the word singular rather than plural because I only had one. Got to pay attention to singular and plural ideas. It would have gotten the name error because, and that's easy to do because it was only off by one letter on there. Okay, so that's a little demo of how you can use the cheat sheet as a quick way to get an overview of the chapter, you know, without having to read, you know, the whole chapter. So let's go ahead and go through the rest, you know, of the part one. I'm just going to go over part one on here. So let's go over a simple example. So in the simple example that you see here, cars.py, let me go ahead and increase the fonts a little bit so you can see it a little bit better. This was the first example out of your book. And let me just go over the ideas here. On line 1, I define my list, cars, and it's got 4 different cars in there. And then I say for car in cars, colon. So in the loop, we're going to perform a test. So we've already gone over the for in loop. What we're learning right here is this two-way branching contrast here, construct, where we have an if statement and we test for a particular condition. So the condition that we're testing is if car is equal to BMW. Notice how I don't have parentheses around here. Parenthesis is not necessary, but it does help readability if you have a very long, if you're doing a lot of ands and ors and stuff like that. So what I'm doing here is I'm saying if car is BMW, go ahead and print it out, but print it out using the upper method. Else, all the other ones, go ahead and just print it out, title case. So when I run it, it does what I wanted to do. BMW is all capitalized. So the loop in this first example checks, you know, if the current value in a car is BMW. If it is, the value is printed in uppercase. If the value of the car is anything other than BMW, it is printed in title case. So this example combines a number of concepts that we're going to go ahead and learn in this chapter. The idea here is that we've got a particular test. If this test is not true, then the else clause will fire. Okay. So that's our first little example here. Let's go ahead and talk about conditional tests a little bit more. So how does the if statement work? At the heart of every if statement is an expression that can be evaluated as true or false and is called a conditional test. Python uses the values true and false to decide whether the code is in an if statement should be executed. If a conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. So if this, like example here, if I didn't have the else, if this wasn't true, then nothing would happen, right? So to check for equality, we use two equal signs. That is the equality operator, okay? Just how we did, you know, at the Python interpreter. When I said car gets BMW, and then I go ahead and say is car equal to BMW? the answer is true. Okay. So the check for equality is done with the equality operator. And in many programming languages, that's two equal signs together. Now, sometimes people want to put a space in between the equal signs, and you can't do that. So basically right now, what I'm asking us to remember, or you all to remember, is when do I use the single equal sign and when do I use the double equal sign? Okay, the first time that I used it here in this terminal window, the first time I used it, like right here, that's an assignment statement. I assign BMW to car, right? Then when the next line of code is the actual test for equality. This one, the first time I did it, I say set the value of car equal to Audi. Then on the next line, you know, where I use the two equal sign, I say, the way you should say it to yourself is the value of car equal to BMW? And like C++ and Java, a lot of programming, most programming languages use equal signs in this particular way. Now, checking a case when checking for equality. Testing for equality is case sensitive in Python. For example, two values with different capitalizations are not considered equal. He doesn't really tell you why, but really the answer to that is that strings are compared really based upon their Unicode or their their ASCII equivalent. So every character has a number. So a capitalized letter has a different number than a lowercase letter. Okay, so it's probably more than what you want to know, but that's how the comparison is actually done. So that when I go ahead and say something like car gets, or car is being set to Audi, in this case, I'm going to go ahead and use a capital A here. If I go ahead and say, you know, is car equal to AUDI? And the answer is false. Okay. I could use the lower method, like I had mentioned here. I already know that car is set to Audi here with a capital A, so I could say car.lower gets, or actually no, is it equal to, excuse me, Audi? And the answer is true, because I temporarily convert whatever is inside of car, which has Audi with the capital A, and I convert it to lowercase and I compare it to lowercase AUDI, and the return is true. So now that brings us to checking for inequality. So let's go ahead and take a quick look at that. Testing for inequality, we'll use this little example up here. And in this particular case, I'm going to go ahead and set requested toppings to mushrooms. And then I'm going to go ahead and perform my test on line 5. So the inequality operator is exclamation point equal sign, whereas the equality operator is two equal signs. So I'm saying if requested topping not equal to anchovies, colon, print hold the anchovies. Let me go ahead and run that. And that's the way it works out. So you need to know how to test for equality and also test for inequality as well. So now that brings us to numeric comparisons. Let's start off with the magic number. So in this particular case, this particular magic number, let's pretend that I prompted the user for a number I'm thinking of, and I'm thinking of, well, maybe I'm over elaborating, but let's just say I prompt the user and they say 17. Okay, so I put that in 17. So then I go ahead and say, if 17 is not equal to 42, then print, this is not the correct answer, please try again. So let me run that. This is not the correct answer, try again. So the reason why that's true is that is 17, is it equal to 42? So this is the test for inequality, okay, the test for inequality. So hopefully let that sink in as to what's being done here. We could do tests for equality as well, numeric tests for equality. And we can do a whole bunch of stuff at the command lines here. But we'll get to that later. We'll get to that later. Let's look at our next example on here. Barred user. So in this a particular example, because we'll put everything together at the tail end, I use a list and I declare it on line 1. And then I'm going to go ahead and set Marie. I'm going to assign Marie to user. And then I say if user not in banned users. Let me go ahead and run this. So Marie, you could post a response if you wish, or Andrew, you may not post a response. Let me go ahead and show you the rest of the code here. It seems to be hidden there. Yeah. So what happens here is I'm making a test. And the first time I'm using the not, the keyword not, and the second time I'm using the keyword in. And then, so I say if Marie is not in these users, because these are the banned users. Banned, in other words, they can't use like a website, say for example. So Marie is not in there, right? So it's true. So then you say you can post. This other example, I assign Andrew to user. And then I say, is Andrew, if Andrew in, this is a really neat way of making an if statement. If user in, keywords in, ban users, if that is true, which it is because Andrew is in there, then we say you may not post a response. Okay. Let's go on to the next one here, Boolean. This was at the tail end, and we'll come back to numeric expressions on the tail end because there was triads that bring it all together for us there. Because there was I kind of like exited out of numerical comparisons because I just remembered that our triads have a lot of them. Okay, so in this particular case, we're looking at a Boolean variable on line 5, and then I test to see if game is active. Is it true? In this case, let me go ahead and run it. In this case, if it's set to true, then I say game is on. Then I set the Boolean to false, and I perform a test again. So then I say the game is off because I set this Boolean variable to false. But then I test the opposite here. I say if game active not true, well then again I say the game is still off. So a lot of times some people have difficulty with understanding when something is equal or not equal to. It depends on the logic. That's why a lot of times people who want to be programmers, they also take the philosophy class, or it's a mathematical class on logic, which really helps you to understand these conditions better, especially when we start dealing with ands and ors, which we're going to be looking at in just a minute. So our first triad, 5.1, let's go ahead and take a quick look at this. Let me run it. Is car equal to Subaru? I predict true. And what I'm doing here in this particular case is I'm printing out the condition. So car equals to Subaru. Is it true? Yes. So it prints out true. In the other one here, is car equal to Audi? And perform the test. Is car equal to Audi? No, it's not. It's set to Subaru. So this expression right here on line 7 will return false. Okay. So Boolean expressions, really important, idea. If I didn't mention it, Boolean's expressions are just another name for a conditional test. A Boolean value is either true or false, just like the value of a conditional expression after it has been evaluated. It is named after the 19th century mathematician George Boole. Boolean logic is a form of algebra in which all values are reduced to either true or false. So let's continue talking about conditional tests, but I'm going to put them in a file instead of running them at the command prompt. Now, when you run them at the command prompt, did you notice you don't end up having to put in a lot of those keywords. You don't need to put in those ifs and all that kind of stuff. So it really condenses things down a lot. Your author went through practically all of this chapter, not all of it, a great deal of this chapter. He did it by running scripts at the terminal window. So he didn't end up doing things like, you know, he didn't have to type in ifs, you know, on there a whole lot. So in this particular example here, what I did here, this is really 5.2, but I cut it up into lots of little pieces because there were really way too many things that were being asked for here. Okay, so in this particular example, I go ahead. Let me go ahead and run it. I set car to BMW, and then I test for equality. In this particular case, I say it tests to true, right? Because my car is a BMW. So if car is BMW, then print out, yeah, it is. But now we use the not equal. So we know that inside of car is set to BMW, so it's not a Ford. So this will fire. My car is not a Ford. Now look at this next one here. And this next one here, test using the lower method. So in this particular case, I'm setting car to Audi with a capital A. And I say if car.lower, if it's equal to Audi, then what? Then say I now have an Audi. So which that works out just fine. I think I'll, you know, so remember, if you want to print out, I think I've demonstrated this before, but if you want to print out what's inside of car, you have to get outside the body of that if and say print. And we go ahead and run that. So as you can see, the value of Audi is Audi with a capital A. Even though I perform a test on line 11, what happened here is that Audi, which would have had a capital A, was converted to lowercase a in a temporary way, and then compared with Audi in all lowercase. It did return true, and that's why the print statement fired. Okay, so this is just a demo of test for equality and inequality with strings. Then we graduate to conditional tests with numbers. So I did a little bit of this and then I cut it short because I've got a lot more examples that will go through all of the examples that we needed to touch on. So let's go ahead and run this and just take it one step at a time. So line 4, I assign 18 to age. And then I perform my test for equality. I say, if age is equal to 18, I just simply say I'm 18, and that prints out, because we know that's true. But then I go ahead on line 8, I assign 19 to age. And then I perform a test. I say, if age not equal to 18, I say I am not 18 anymore. Does that fire? Yes, it does. It fires because age is set to 19. And then on line 12, I say, if age greater than 18, print I'm greater than 18. And now for the last demo, I say, if age greater than or equal to 19. Does that fire? And yes, it does. I should have also put in examples for less than or equal to, but they're the exact equivalents of what you see there on 12 and 15, except in the opposite direction. Okay. A lot of people get mixed up with greater than or less than sign because it doesn't include that number. Some people think that it does. So if it does get you mixed up, when you make comparisons, use greater than or equal to or less than or equal to. Let's go ahead and go on to our third one here. In this test, go ahead and run it. In this particular test, there's more code down here. In this particular test, we're going to test using the and keyword and the or keyword. So it's a lot of code on there, a lot of code, but we'll just take it one step at a time. So the first thing I do is I assign 19 to age, and then I assign true to wealthy. So wealthy is like a Boolean variable, and age is like an int, right? So remember, I can put parentheses. Some other languages require it, but Python does not. It does increase readability, many people say. So use parentheses if you feel that it helps the readability of your code. But parentheses is optional. So let me read line 5. It says, if age is equal to 19, which it is, that part will be true. And if wealthy is equal to true, and it is, then it would print out, I am 19 and wealthy. This is nonsensical, but if you read the chapter of the book, it said this is do-it-yourself 5.2. It said create all these different kinds of tests, and it was really quite a lot of them. So I cut them up into smaller parts on here to make them more manageable. Otherwise, they just go on and on and on and on. Okay, so now, so everybody understands I am 19 and wealthy. Then on 8, it says age is set, changed from 19 to 20. So what I'm doing here is I'm assigning 20 to age, and now I perform another test. And it says, if age is equal to 19, which it isn't, right? Or, this is an or. And it's really important to understand the logics of ands and ors. There's some parts that are difficult to understand. Like an and, well, obviously both of them need to be true, but with the or, either one of them could be true, or really both of them could be true, so that it only fails when both tests are false. So this is not, so in other words, it's not an exclusive or kind of situation. And we'll test that in just a minute. So for right now, I'm assigning 20 to age, and then I go ahead and I print out the value so I can see, I want to see what age is set to. So age changes from 19 to 20, I know that. Am I 19? False, I'm not 19, I am 20, right? And then am I wealthy? Wealthy is printed out here. The state of that is, is wealthy equal to true? And yes, it does print out as true. Now, in this or situation is printing out because this condition here evaluates to true, right? Let me see what happens if I put a little comment in front of line 9 and run it again. When I do that, I see, well, that's the top part. We need to go down. So, am I 19? The answer is true now. Before it was false. Why? Because I commented out the line 9, changing it to 20. Before it was false. Okay, so that gives me a true, situation, on here, right? But what if I set that one? If I have age and wealthy to, if I set that to false, and that's with a capital letter, run it, what happens then? Well, none of this stuff is printed because it fails when both tests fail, my friends. Okay, so I'm going to comment this part out right here and run it again. And I am not 19. Oh, excuse me, where is that one? I think I did that already, right? So am I 19? False. Am I wealthy? True. So the or is true. So wealthy. Oh, I guess I shot that wealthy idea a little bit early here, because I go ahead and change wealthy to false, and then I perform the test again. But this is interesting here because I'm using a two-way branching construct here. And that means that if the if clause doesn't fire, if it's not true, then the else clause will fire. And that's why it says, I am not 19, nor am I wealthy. Okay. If I wanted to, I could go ahead and put in, the little tests here for age and for wealth to see what the current status of those Boolean variables are. Okay. Last one I've got on here is to test whether an item is in a list. So let's go ahead and create our list first. In this particular case, on line number 2, I create my list, and the list is plural. But then I go ahead and set the, I'm going to search. I set friend to Devin. I could have just put Devin inside the if thing, but I went ahead and assigned it to a variable. I think it looks cleaner that way, right? This way it could be like you could be prompting the user for something, right? And then getting that and then using it in this if statement. So if friend in friends, which is a really unique way of performing a test on here, note the keyword in. This is the keyword in is being used here. So if Devin is in the list, then I go ahead and say Devin is my friend. Let me go ahead and run that. So Devin is my friend. And then I test whether an item is not in the list. And that's being done with the not keyword, or should I say not in keywords. So I assign John to friend. And then I perform the test if John not in friends. And that condition is true. So that means that line 10 will fire, and it will say, John is not my friend. And it does that using, I'm using the title method on the string, because these are string methods, right? These string methods are predefined by the language, and I'm using it so that it looks a little nicer when I print it out on the screen here. Okay, so that's the first part 1, which includes a simple example and conditional tests, which are Boolean in nature. And remember, Boolean named after George Boole, and things are going to be either true or false. And Boolean conditions are used a lot by advanced programmers to test for a particular condition. So an if statement evaluates to a Boolean condition. If it's true, something happens. If it's not true, then the else clause fires. We will examine this idea in much more detail in the part 2 of this chapter, which we will go over not only single or simple if statements, we'll talk about two-way branching constructs, we'll talk about using elifs or multi-line testing, and then in part 3, we'll go ahead and cover using conditionals inside of lists in more detail, and talk about styling, how it's really important. Whenever we talk about styling, we're talking about things like indenting and white space, and because if you're coming from another language, we used to, like in Java, we use the open and close curly brackets. You don't have that in this language, right? So right after that colon, we have an indentation, and that's how it knows that it's part of this suite, right? It's a body. It's everything in that if it's indented, will be fired because of the way it's indented. And if you don't indent properly, you're going to go ahead and get some syntax errors. You'll get syntax errors, for example, if you forget the colon. I think we've been there before. We'll run that to you, right? It's syntax error, invalid syntax, right? You'll go ahead and get syntax errors if you do not properly indent, right? So in this particular case, I did not indent, indentation errors. But sometimes you'll end up with some logic errors, and we'll be talking more about those, as the chapter evolves. All right, well, that's my rendition of part 1 of this chapter. Be talking with you later. Thank you.